So I want to repeat what I've done in class last time and then expand on this as well. And this is about odds ratios and prediction equations. So I want to get started by writing out the three formulas that are important about exponential functions. And so the first one is e to the power of 0 equals to 1. The second one is e to the power of a plus b is the same as e to the a times e to the b. And the third one is e to the power of a times b is the same as e to the power of a to the power of b. So that's important. We'll keep those on the side and we'll keep them in mind. And those are the three that we'll be using. I want to get back to the in-class exercise. So from the in-class exercise, and the notes here, pretty much the same ones that I'm writing out here right now, or have also been scanned in as a PDF document, and those are my handwritten notes that you can find on Canvas. So in the in-class exercise, we had a model where eta ij was gamma 0, 0 plus gamma 0, 1 times male ij times gamma 0, 2 pre-primary education ij, and then the error terms. And that's an ij here. So from the output of that model, we could write the prediction equation as being negative 2.03 plus 0.46 times male ij minus 0.56 times pre-primary education ij. Now if we want the prediction equation for y, we have to take the exponent of both sides, the left and the right side. On the left side, we're getting y prime ij, and on the right side, we're getting e to the power of this entire equation. So I'm just going to write this out real quick, and I'm going to start using just, now let's do it properly. Write out everything. And so now we need to use our formulas on the right side. So let me see if I can move this down just a little bit, just enough here to have space. So now we have this term here, and we're going to write this out and decomposing this into a product term. We're going to use the second rule, e to the power of a plus b, and we got three terms. We got the first one, we have the second one, and we have the third one. So it's e to the negative 2.03 times e to the 0.46 times male ij times e to the negative 0.56 times pre-primary education. I'm going to write in this box, gets a little bit messy. Now we need to also then decompose the product terms that are now there. So we have 0.046 times male, and we have negative 0.56 times pre-primary education. So we're going to use rule 3 to do that. So we're going to copy the first term, and then the second term is e to the power of 0.46 to the power of male ij, so the gender. And then we have e to the negative 0.56 in this entire term to the power of pre-primary education. Okay, now what we're getting here there is e to the power of negative 2.3 is the odds ratio of gamma 0, 0. And what we have here would be the odds ratio of gamma 0, 1. And then the third term is the odds ratio of gamma 0, 2. And those are the ones that we have in the output. So we can rewrite this equation after doing either copying the odds ratios or plugging the numbers into the calculator. And what we get is 0.13 times 1.59 to the power of male ij times 0.57 to the power of pre-primary education. Okay, so that's that part. Let me move this up again a little bit, and it's a little tricky. So now we get our prediction equation. And what we can do now is we can talk about the four cases that actually apply here, because as you know, both predictors are binary. So we have male or female students, and we have those with or without pre-primary education. So let's say case 1, we're having the prediction equation if a student repeats a grade, and let's say we have a male student, and I'm going to erase this. We're going to not do it this way. I'm going to have to do this way. So let's go back. Now we got it. So we're going to take a female student who had no pre-primary education. And the prediction equation for that female student is 0.13 times 1.59 times 0, because that's the gender coding, times 0.57 to the power of 0, because this female has no pre-primary education. Now, we're going to use rule number 1. Any e to the power of 0 is equal to 1. So we're getting 0.13 times 1 times 1, which is 0.3, which now you see that the odds ratio of the intercept is equivalent to the prediction for a female with no pre-primary education. Second case, and now we have a couple of options. We're going to take a male student with no pre-primary education, and so just filling in the numbers, 0.13 times 1.59 to the power of 1 times 0.57 to the power of 0. To the power of 1, anything is just the same as the number, as the base, and this is equal to 1. So what we get here is 0.13 times 1.59, and if we plug this into the calculator, what we're getting is 0.21, and so forth. What I want you to do right now is I want you to stop this video as soon as I'm writing out the next step, and I want you to complete the calculations, and now I have to erase this again. Complete the calculations for the last two cases that we can have, and that would be a girl with a pre-primary education, and then it would be a male, a boy, with pre-primary education. So go ahead and do this, and if you do it right, you should get 0.08 and you should get 0.12. So that's the first part of this. Go ahead. So let's add an interaction effect. We have so far had only level 1 predictors, but the interpretation really doesn't matter. It's just that you know where your data are coming from. So let's say in our example, hypothetically, let me start the pen again. So hypothetically, we have added an interaction effect between gender and pre-primary education. So, and let's assume that the results are as follows. I didn't change the numbers for the direct effects, which is not going to happen in real life unless the interaction effect is really 0. But just for this example, we're going to keep it this way. And then I have 0.02 times gender times the pre-primary education at this point. So if we're writing this out, I'm going to do this a little faster now. As before, we know that this is e to the negative 2.03 times e to the to the power of 0.46 to the power of male ij times e to the negative 0.56, and this whole thing to pre-primary education, and then times e to the 0.20 to the power of male to the power of pre-primary education. So that's the formula. So let's say we're replacing this again with the odds ratio. You're going to put this in parentheses, into brackets. Then we can say as earlier, as a 0.13 times 1.59 to the power of male ij. So all still the same, times 0.57 to the power of pre-primary education times 1.22 to the power of gender and to the power of pre-primary education. So just as we've done before, we can now plug in numbers. The most complex example would be that we have a prediction equation for a male with pre-primary education. And we're just going to plug it in. So 1 for both male and pre-primary. 0.13 times 1.59 to the power of 1 times 0.57 to the power of 1 times 1.22 to the power of 1 to the power of 1. So we're just going to multiply all these things out because anything to the power of 1 is the same as the base number. And so you will just multiply all these things out and you get 0.02. Okay. Now let's say, this likes to jump around on me. Let's say we want to know what's the prediction for a female with pre-primary education given this interaction effect. So it would be 0.13 times 1.59 to the power of 0 times 0.57 to the power of 1 times 1.22 to the power of 0 to the power of 1. So this is 1. This is 0.57. This in here is 1, which means the total thing is 1. So it's the same thing with an interaction effect. In a regular regression, if one of the terms is 0, the term just falls out. And in case of multiplication, that's multiplying by 1. So for a girl with pre-primary education, the prediction equation is going to be 0.13 times 0.57, which is what we already had before. And I would have to look this up, and that would be 0.08 because there's no interaction in this case. So lastly, I want to talk about continuous predictors, and I mentioned this in class. A lot of people who do logistic regression or logistic multi-level modeling like to dichotomize all their predictors because they don't know what to do with an odds ratio, and it's a little bit more complicated with an odds ratio that is not based on a dichotomous or binary predictor. So I want to look at age. It's one of those classical things that you might see people putting decades onto people, putting them into categories that are large enough to then dummy code or to run as just, you know, as a dichotomous predictor. So let's say we're taking age, and let's say in our case we center, because these are 6th graders, I believe, 7th graders, 6th graders centered at 12 years. And as the average age of a 6th grader. And then we say the odds ratio that we get spit back from the software is 1.2. Okay, so for a child that is of age equals 10, we would get our odds ratio for a 10-year-old would be 1.20 to the power of age. In general, that's what we get. So remember we would have the gamma times gamma 0.3, would this be in our case, times age, and if we exponentiate this, we will get e to the gamma 0.3 times, hold on, that's wrong. Let me fix that. To the power of age, which the e to the power of the gamma is our odds ratio, to the power of age, which in our case I chose to be 1.2. So if a kid is 10, that means that age is coded is -2. And to the power of -2, just in case anybody remembers, would be the same as dividing by 1 to the power of 2. But you plug it in the calculator and you get an odds ratio of 0.69 for a 10-year-old. So what happens if we have an 11-year-old? We get the odds ratio of an 11-year-old to be 1.20 to the power of -1, which is the same as 1 over 1.20, or if you don't care for the fraction, just the calculator, 0.83. And I'm just going to keep going so that this starts to settle in. So a 12-year-old is just the average age, so that would be coded as 0. So that's our reference odds category, right? So that's what we're getting here. And then we have age 13. So a 13-year-old gets coded as a 1. So the odds are 1.20. And then we got 14. And the odds ratio of a 14-year-old is 1.20 to the power of 2, or squared, which is 1.44. And then let's say we have a 15-year-old in this batch as well. The odds ratio for 15-year-old would be 1.20 to the power of 3, or the calculator will tell us this is 1.73. So this is what you do, and you would do the exact same steps for any other continuous variable. And so we don't have to dichotomize exactly what's going on in there, but sometimes that might be meaningful, especially if you think that those relationships are not exactly linear.